well, we're just going to list out all the different ways you can solve a system of equations that we know of, right? It can be ones that we have or haven't done thus far. What are some of our methods? Right, the one we did yesterday, perfect. What else do we got? Are you raising your hand? Elimination, good. What we're doing today. Okay. There's a method that you guys used a lot last year on your calculator.
Is it graphing?
Yes, graphing. So you can just put the two equations in y equals and graph them and find their intersection point, right? Okay, and then this fourth one may or may not be something you remember from Algebra 1. You may not have dealt with it much, but you will use it a lot in Algebra 2 for solving your systems of equations. And that is using matrices. Okay. All right, so there's all our different methods. Let's go ahead and dive into elimination. So when we are using elimination to solve our system of equations, the goal here is to eliminate one of the variables. By combining your two equations. And then just like yesterday, we want to have the steps in order to solve by elimination, so we're going to fill those in ourselves here today. All right, so the first thing that you want to do is make sure your equations are lined up, right? You want your x's over your x's, your y's over your y's, your constants over your constants. Typically, that means we want it in standard form. So make sure equations are in standard form. And remember, standard form, the way that looks is ax plus by equals c. So your x first, then your y is equal to the constant number, right? Okay, so once you have your equations written that way, or you've got everything lined up, you then are going to manipulate one, maybe both, or both of your equations so that one variable has the same coefficient. But while we want it to have the same coefficient, we also want it to have opposite signs. Okay, so we would want them to have the same number in front of them, but we would want one of them to be a positive number and one of them to be a negative number so that they will cancel out or eliminate, like our goal. All right. So once you have those opposite signs, you then combine your equations by adding like terms. And if you did it right, one of your variables should cancel out at this point, right? So one variable should cancel. Okay? And then once you've solved for that one variable, the process then goes back to exactly how it was yesterday. Now that you know one of your solutions, you can go back and plug it in to one of your original equations so that you can find the other. So then you just solve for other variable. And in order to do this, you would plug into an original equation to solve for the second variable. And of course, if you want to, you can always check your answers by plugging into one of those originals, right? And how do we always want to write our answer? How do we always write our answers yesterday? Yes. Very good. We always want to write our answer as an ordered pair. Remember, like some coordinate point, x, y, right? So don't forget to write it that way once you find both x and y. Okay, so let's look at some examples here. On number 1, okay, remember, step 1 said we want them written in standard form or we want them lined up. Do we have that here? Yes, we got x's over x's, y's over y's, constants over constants, right? Okay, and then step 1 was if it's not already written that way, you need to manipulate one or both of the equations so that one of your variables has the same coefficient but opposite signs. Do we already have that? Yeah, those y's already have that taken care of for us. So we didn't have to do anything there. And then our step 3 is to combine the equations by adding like terms, right? So basically, I'm just going to add these two equations together. So first we add the x's. 3x and 2x would give us, good. Okay. Then negative 4y plus 4y. What's going to happen there? All right, so that one's 0. You don't have it anymore. Is equal to 13 plus 2. Right. And then we solve for this remaining variable. So what would we do here? Very good. And we would end up with x is equal to, very good. All right, so we found x. Now all we have to do is find y. And how are we going to do that? Plug into one of those originals. Doesn't matter which one. Maybe you choose the bottom one since the coefficient is smaller to keep your number smaller. If you did that, you'd have 2 times 3 plus 4y equals 2. Okay, so what is 2 times 3? Good. Then what would we want to do? Very good. So I'd end up with 4y is equal to negative 4. And then divided by 4. Right, what is negative 4 divided by 4? Negative 1. Very good. So y is negative 1. And how do we want to write that answer? Right. So our solution is 3, negative 1. And again, remember, if you wanted to check this, you would just take those two solutions and plug them into one of those equations up there, right? Okay, so maybe I plugged it into the top one. We're not going to check them both. But if I plug in the top one, I'd have 3 times 3 minus 4 times negative 1 equals 13. Well, we know 3 times 3 is And negative 4 times negative 1 is positive 4, which does equal 13, right? Okay. All right, let's look here at number 2. Okay, do we need to rearrange the equations? Do we need to manipulate one of them to have the same coefficient and opposite sign? All right, so we are ready to go ahead and add. So what happens to those x's? Right, we have a 0 there. So then we add our y's and we get good. And then we add our constants and we're going to get very good. So y must be right. Okay, so I now know y. What am I going to do to find x? Okay, you guys want to use top or bottom equation? Top, okay. So we would have x minus 3 times 6 equals 5. Okay, well, what is 3 times 6? 18. All right, so we've got x minus 18 equals 5. And then what? Right. So x is good. So we need to write our answer as that ordered pair. And then if we were going to check this, we would just go and sub it into either one of those equations. If I picked the top one, it'd look like 23 minus 3 times 6 equals 5, or 23 minus 18 equals 5, which is true. Okay? All right. Flip it over onto the next page. All right. These are not in standard form, but is everything lined up? So you could still solve it this way. You also could change it into standard form if you wanted. I want you guys to go ahead and solve this one, and then we'll come back together here in just a second and check it. All right. So on number 3, you guys already talked to me about this a little bit. We said everything is lined up, so we can leave it as it is, and we do already have something that should cross out, right? So if we add those y's together, we get good. And what's going to happen to our x's? Then 8 plus negative 4 is very good. All right, so then we just divide. We end up with y is good. All right, and now that I know y is 2, how am I going to find x? Right. Did you guys use the top one? Yeah, okay. So you'd have 2 is equal to negative 3x plus 8. What do we do then? Okay, so 2 minus 8 left us with, so negative 6 is equal to 3x, so x is good. So solution here is 2, 2. All right, and I already saw some of us working on number 4. So what happened here when we added together? All of the variables canceled. So on this side, I've got 0, right? Okay, what about on this side over here? 40. Well, does 0 equal 40? So what does that mean my answer is? No solution. Very good. Okay. So this is what's going to happen if you're left with a false statement like this, right? You also can use this symbol here. It represents no solution or the empty set. Okay, so speaking of the different cases we can have, okay, I already saw some of you guys graphing these, which is a great way to check your work. If you want to graph in the calculator just to make sure that you got the right solution, that's a great thing to do. First of all, we can obviously get the solution that we've gotten on most problems so far, right? Some coordinate point x, y. Right? If we were to graph two lines and we get this as an answer, what do the lines look like? So if we get a coordinate point, that means that they intersected, right? All right, so they can't be parallel if they intersected. So we know that parallel lines look like this, right? They never touch. So these have to intersect at some point somewhere, right? So we should have two intersecting lines if we looked at the graph and had this answer. Okay. What if we end up with a false statement like we did here? Like 2 equals 4 or 7 equals 0. Then what was our answer? No solution. Very good. No solution, or this symbol here. What would that look like on a graph? Parallel lines. Very good. Because they would never touch. We would never have some intersection points. Okay? What if you were to solve something like this and it actually gave you a true statement like 0 equals 0? What would those look like? Infinitely many solutions. Very good. Okay, and if those were a graph, they would be, I heard somebody say it, the same line. Nice. Okay. So we've got another one here where they didn't give us having opposite coefficients already, right? So we're going to have to do something to fix that here. What do you guys think we should do to fix that? What could we do? Yeah, we can multiply one of these by some value, right? If I wanted the x's to cancel, I'd have to multiply the bottom row by something, right? If I want the y's to cancel, then I could probably just multiply my top row by something, right? If I multiply the top row by something, I can multiply it by a positive number because the signs are already opposite, right? If I'm going to do the bottom, I'm going to have to multiply by a negative. Either way works, right? Let's say we're going to multiply top row. Okay, if I multiply top row, I could just multiply it by a positive 2, and that should fix things, right? So we'd have 2 times 3x, which would give us, right, 2 times negative y. Very good, and 2 times 8. All right, and I'm going to keep the bottom one exactly as it is. And now we should be good to go to combine these two equations, right? So when we add the x's, what do we get? Good. Our y's, just like we had hoped, will eliminate. And 16 plus 5 is good. So x must be very good. All right, and then to find y, we take that answer and plug it into an original. Do you guys want to use the first one or the second one? Second, okay. So we would have 3 plus 2y equals 5, right? Then what would we do? So we end up with 2y equals, good. So y must be very good. So in this case, our solution is 3, 1, right? So sometimes that happens. Sometimes you are going to have to multiply one or maybe both of your equations by something to fix it, all right? Okay, and then last question is a word problem. So we are going to solve it using elimination, but we set the equations up just like we would on those ones that you guys were looking at yesterday on the substitution side of things, okay? So it says that there's a hockey game. 2 families are going to this hockey game. One family purchases 2 adult tickets and 4 youth tickets for $28. Another family purchases 4 adult tickets and 5 youth tickets for $45.50. Let X represent the cost in dollars of 1 adult ticket and let Y represent the cost of dollars in 1 youth ticket. Okay, so they already told us what our variables are representing, right? So that's my first step. They said X is representing the amount for an adult ticket, and Y is representing the cost of a youth ticket. Right? Okay? So, if we're going to solve this using any method, we need some equations, right? So I'm going to base that on the information they gave me. So for family 1, they purchased 2 adult tickets and 4 youth tickets for $28. How could I write that as an equation? Yes.
2x plus 4y equals 28.
Right. 2 adult, which we said is represented by X, so 2 of the adult tickets, and anytime we see that word and, we know we're using addition. 4 youth, Y is representing youth, cost them a total of $28. Okay, if we're going to solve this, we need a system of equations, so we need a second equation. So that next sentence, another family purchases 4 adult tickets and 5 youth tickets for $45.50. How would I write that as an equation? Good. All right. Okay, so if I was going to solve using elimination, do we have everything lined up? Yeah, so they're lined up. Do we have anything that's going to eliminate when we add? So we're going to need to fix that, right? What would probably be the easiest fix here?
Multiply the top 2.
Not just 2, but -2, right? So I'm going to multiply that whole top row by -2. Okay? Alright, so when we multiply that top row by -2, I'm going to have -2 times 2x, -2 times 4y, and -2 times 28. And then that bottom equation we're not going to change, right? Okay, so now hopefully when we add these together, something eliminates, right? So there go those x's. Alright, I also have -8y plus 5y. What's that going to give us? Very good. And then I have -56 plus 4550. What's that going to give us? Good. -1050. Then what should we do? Right. So we end up with y is equal to not negative, right? A negative divided by a negative is a positive. Okay, so we found y, now we just need to find x. And how am I going to do that? Right, plug it into an original. So maybe we use that top equation that we had here, so I'd have 2x plus 4 times, I now know y is 350 equals 28. Okay, well, what is 4 times 350? Good. Then what should we do? Good. So we end up with x is, very good. Okay, something I want to point out to you guys, in a word problem, sometimes you use variables x and y, sometimes they give you other variables to use, right? Like on yesterday's, it was you could use C and P for candy bars and pretzels. If you were to write something in an ordered pair that's not x and y, you write them in alphabetical order. But typically in a word problem, they're asking how much did that specific item cost, or whatever it is they're talking about. So you would just tell me in words, adult tickets cost, this one's the adult, right? So it was X, $7. And youth tickets cost $3.50. Okay. All right. And you guys already have the assignment that goes with this. So you'll be doing the back page today. We are going to be moving on to our next lesson tomorrow. So you are expected to complete it this evening, have it ready to go tomorrow. If you have a question, email me your question. If you email me outside of school, I won't be able to get back to you until the next morning, most likely. But I will get back to you. I'm in here starting at 7:45 in the mornings and after school, right? So you have two opportunities. You could come by and ask me a question or send me an email if you come across something you have trouble with, okay? All right.